Welcome to lesson 2.3. We're going to title this One, None, or Many and go ahead and set up your Falcon notes. So our essential question for today are what are the different types of solutions that we can have? So when we are solving linear equations, we have three different types of solutions that we can look at. We have one solution, infinite solutions, and no solution. So we're going to look at what each type of those solutions looks like. When we have one solution, we typically solve for x just like we normally would, and we usually end up with x equals a number. That is what one solution looks like. So if I look at this example, I'm going to go ahead and solve for x. I'm going to first split up my equation into two sides. I see that I have one x, but I have a 4 and a 2 attached to it, so I need to get rid of those two things. So the first thing I want to get rid of this is plus 4. I'm going to get rid of that by subtracting 4 on both sides. And when I do that, my 4's cancel. I bring down my 2x and my equal sign. Negative 8 minus 4. These are the same sign, so we keep the sign and then we add the numbers. 8 plus 4 is 12. So I have 2x equals negative 12. And then I want to get rid of my 2 out in front of the x. So these are attached through multiplication. So we have to do the opposite of that, which would be division. So I'm going to divide both sides by 2. My 2's cancel, and I'm left with x equals, and negative 12 divided by 2 leaves me with negative 6. So what you can see here is I only have one solution. I have x equals a number. It doesn't equal more than one number, it's just this one number. So this is an example of when we have one solution. Now we also have examples when we may have infinite solutions. So what this looks like is when we solve for x, we end up with a true statement. Now remember, a true statement is something that is obviously true. For instance, 3 equals 3. We know that 3 most definitely does equal 3, or 4 equals 4. An untrue statement would be something like 2 equals 3. That's not true. 2 does not equal 3. So when we solve and we end up with a true statement, that means that we have infinite solutions. So let's look at this first example. I have 3x plus 5 equals 3x plus 5. Right away I can see that these are the exact same thing on both sides of my equal sign. So if you don't want to go any further from here, you can already say that this is a true statement, so you have infinite solutions. But if you want to just make sure, you can go ahead and solve through. So when we solve for x, usually we want to get one x, and this time we have two x's. So because we have two x's, we want to move both x's to the same side. So I'm going to take one of these three x's, it doesn't matter which one, and I'm going to move that. So I'll move the x on my right-hand side. This is a positive 3x, so I'm going to subtract 3x on both sides. When I do that, I have 3x minus 3x. Those cancel out, and I'm left with 5 equals. And then I also have 3x minus 3x again, so those cancel out and I bring down my 5. So I'm left with 5 equals 5, which is indeed a true statement. So what I would say here is I have infinite solutions. And what infinite solutions mean is that any number that I plug into this equation for x is going to be true. So if I were to plug in 2 for x, 3 times 2 plus 5 is going to be 3 times 2 plus 5. I have 6 plus 5 equals 6 plus 5. I have 11 equals 11. So 2 works here, but literally any number could work for x. If I did 3 times 1 plus 5 equals 3 times 1 plus 5, you'll see that this also works. So this would be 3 plus 5 equals 3 plus 5, which gives me 8 equals 8, which is another true statement. So when we have infinite solutions, that just means any number could work for x. So instead of writing out a million different numbers that say x equals this, x equals this, x equals this, we could just say infinite solutions. So let's look at another example. I have 1/2 x minus 7 equals negative 7 plus 1/2 x. So these equations are really similar. I can see that I have 1/2 and I have minus 7. But they are written in different orders. I have 1/2 x on the end of this equation, whereas on the other side I have it at the beginning. The order shouldn't matter, especially with addition, and we've kind of talked about that with our commutative property. As long as you keep the same signs that are in front of your number, you can kind of reorder them. So I'm going to keep this left-hand side of my equation exactly the same, but I'm going to reorder the right-hand side. So I'm going to actually move this 1/2 x to the front. Since it's positive, I'm going to keep it positive, and I'm going to move this -7 to the back. And since it was originally -7, I'm going to keep it as -7. So in reordering, you can tell that now I have the exact same equation on both sides. And again, if you have the exact same thing on both sides of your equal signs, this just means that you have infinite solutions. So I have put a little star over here. It says if the equation is the same on both sides of the equal sign, there are infinite solutions. And that's kind of what we just saw in those two examples. Our last solution type is when we have no solution. This happens when we solve our equation and we end up with a false statement. So let's look at this example. We have 2x minus 4 equals 2x minus 5. I'm going to split the equation into two. I have two x's here, and typically we only want one, so I need to move one of those x's in order to put them on the same side. So it doesn't matter which one I move, I'm just going to move this positive 2x, and I move it by subtracting 2x. When I subtract my 2x, I can see I have 2x minus 2x, and those cancel. I bring down my minus 4. And then I have 2x minus 2x again, those cancel. I bring down my minus 5. So I end up with -4 equals -5, which is a false statement. -4 does not equal -5. So we would just say here we have no solution. So in summary, we have three different solution types. We have one solution, and we get one solution when we end up with x equals a number. We have infinite solutions, and we get infinite solutions when we have either a true statement or if we have the same equation on both sides of your equal sign. And then we have no solution, and we get no solution when we have a false statement. For example, 2 equals 3. That's a false statement. All right, that is all our notes for today. I will see you guys in class. Bye.